Welcome. Today we are going to talk about another interesting phenomena in auction. In fact, this is about computing the auction problem. In fact, in online environment this is even a more important problem. Last class what we discussed? We discussed how to design the auction rule. This is a strategic level discussion and level decision making situation, but once that rule of the game is decided about the how to conduct the auction, how to determine the winner, etc. Now, determining the winner, who will be the winning bidder is the next problem. So, here in this lectures we are going to learn about winner determination problem under various setting. To start with, consider a very simple scenario in which you have a single item with single unit under selling, and you have naturally the item will be going to the only one winner, and it is a forward auction and the bids are only price bids. Okay. Now, the situation goes like this: people who have little bit idea about linear programming, integer programming, etc., they will be able to understand this, but others can also understand because it is a fairly written in a fairly simplistic manner. In fact, when we go for complex auction format, I will not be talking about it, but at least to give you a feel that there is a mathematical angle to it, I am explaining this one. Let us say, what is my problem? My problem is to discover who is the winner who pays me the highest value. Naturally, it is a sorting problem. I will be sorting all the price bids and whosoever gives me the highest, I will be choosing that, but there is a mathematical angle to it as well. So, what is that winner determination problem? The winner determination problem is I try to maximize my sales revenue, where by multiplying I associate a variable x I with each of the bid. Let us say I have 10 different bids, 10 different bidders participating and all of them simultaneously submitting the bid. So, first person's bid I represent by x 1, second person's by x 2, and all of them are binary variable. By binary variable we mean if the person wins, x I becomes 1, if the person loses, x I becomes 0. Now, the point is I have to determine which one of these x I should be 1. So, what do I do? I maximize p I into x I. So, if fifth person is the winner, so x 5 p 5 that will give me the my revenue. So, and sum of this should be less than equal to 1. So, though the mathematical problem appears to be an integer programming problem which is little bit complex, otherwise if you solve using traditional integer programming solution approach, but here it turns out to be a sorting problem and I solve it by simply sorting all the bid values, but all the auction formats will not be that simple. There can be multi-unit auctions which can be forward auction or a reverse auction. It can have many constraints like the bid can be divisible. I mean by divisibility we mean in fact, we are going to discuss more about it. Similarly, I can have multi-unit auctions, multi-attribute auction, double auction. In fact, about all this while talking about how to distinguish between various auction types, how to classify them, we have discussed about all of them little bit. Now, we are going to see about more of this. So, first one is let us start with a multi-unit auction. In case of a forward auction, it is maximization of selling price. In case of a reverse auction, it is minimization of the procurement cost. Look, a situation in which a multi-unit auction is happening with divisible bids. By divisible bid we mean, now look, here if you look at this, you can even if you connect it with the earlier lecture of how to classify the auction. Once we said that we can classify based on the nature of the bid. Look, in the first case it was price bid only. Now, we have a bid which is a pair of price and quantity. So, bid represent a price quantity pair. So, here the first person's price is 20, quantity is 30 and so on. In case I go for divisibility of the bid, suppose my I am trying to sell some 100 units and these are the units asked by various people. So, if I allow divisibility of bid, so or my buyers are willing to purchase less than what they specify, then my option will be like this. I will be, look here, see the point that I am going to, you must be thinking why I am showing this mathematical formulation. The point that I am going to make is, from the very beginning I have told you we are going to discuss about decision making situations mostly related to online business activity. Now, while discussing about decision support system, I told you decision support system can be either model based, model driven, or it can be data driven. About data driven, some few examples about your customer behavior modeling, about your recommender system we have seen. But in case of model based, so far we have not seen any example situation. Here is the example situation. This is called a model. So, such kind of behind every model based decision support system, there will be a model of this type. My sole purpose of showing you this mathematics is making you understand that when you talk about a decision support system and talk about a model driven decision support system, we have such a mathematical model in the background. So, but right now you do not worry, because basically when I offer this course to our students, they have a background on this. So, discussion makes relevant, but here anyway for simplistic problems I will try to explain little bit, and for difficult problems, and if you have taken the courses on optimization, decision modeling, linear programming, etc., it is anyway becomes very obvious to you. So, here the idea is to sell some 100 units to whom, because nobody wants exactly 100 units, they want in fractions. First person wants 30 units, second person 30 units and so on. So, what do? I now this is a forward action and I am trying to maximize my profit. So, if I maximize my profit, then I sum over P I into X I, where P I is the price and X I is the unit that is being sold to a particular person, and each X I, let us say this is the ith bidder, the amount what he will be getting should be less than the quantity he has demanded. Okay? And all these X I, C, X I are here real variables, they are not no more integer variables. And total quantity I sold, sum of all these X I's should be less than equal to Q. This is again even if in spite of this complex looking mathematical formulation, it is a very simple problem again. How do you solve it? You sort all the bids based on their price, okay? And the person who is offering highest, in this case this is the highest bidder, you give him the total quantity. So, out of 100 units now 70 units are left. Now, he is the second highest bidder, you satisfy his demand. So, 50 units you are selling, he is the third bidder, satisfy his demand 30 units. So, 80 units you are selling. Now, this is the fourth bidder, his price is some 15 rupees or $15 or something, and his quantity is 60 units. So, now I have already sent sold 80 units, I have already decided to sold 80 units. So, next 20 units I will be selling. Okay. So, this particular problem again can be solved as a in case of the bids, the bidders agree to take consider this divisibility, they agree to even purchase less even if they are asking for more, then such a situation arise. Now, situation becomes little different if they are not willing to do so. So, in that case what do I do? I will be solving this problem in which I have to select which all suppliers are within my quantity and still they provide the highest price to me. So, this is a typical knapsack problem situation, and knapsack problem you need not think about what a knapsack problem is if you do not know. People with optimization background will be knowing, and their typical algorithm to solve this is branch and bound. But here also you can solve it very easily. How? Sort it, and after sorting the highest bidder gets the full amount, second highest bidder gets the full amount, third highest bidder gets the full amount. The moment you encounter a bidder where you are not able to fulfill the total demand, you stop. That can be a greedy algorithm of for solving this problem. Okay. So, now situation even becomes complex. The bid type is now complex. You have a multi unit reverse auction with price schedule for volume discount bid. Here the situation goes like this: everybody provides a bid of this type, they provide a price and a range within which this price is valid. So, if let us say this is a situation of two bidders, where the first bidder offers $100 for first 30 units and $50 for between 30 to 40 unit. So, as I buy more, the price drops. So, this is the price schedule provided by the second supplier. So, he will be giving one value, such valuation for the first range, another such valuation for the second range, and so on. Now, the situation in case of the first supplier is a bit different. First 10 units $100, second 10 units $80, next 10 units $60, and finally, next 10 units $40. Now, I can have many constraints here as well. I should be buying some quantity from supplier 1 and some quantity from the supplier 2. So, how much to buy from supplier 1 and how much to buy from the supplier 2. My total demand is some 60 units. So, there will not be a very straightforward formulation to solve this. So, what will happen? There will be a formulation which I have not mentioned here, that formulation will look quite complex and it is very difficult to explain to everybody without proper background in optimization. So, therefore, I just show you the optimal solution in this case. Considering all the combinations of the price ranges, the optimal solution turns out to be 30 units from each bidder I will be buying. You can try yourself. If I decide to buy something else, some other combination, let us say my demand is 60, I buy 20 from here and 40 from here. So, how much I end up paying and how much I end up paying in this particular case. Okay. So, this particular problem is a multiple choice knapsack problem. So, the bidding system that you are implementing will be solving such complex optimization problems with appropriate algorithms. This is again another situation. This is a example of a multi-item forward auction. Again, do not worry about this formulation. Let us try to simply understand the winner determination problem. Suppose it is again a selling kind of auction, where my aim is to maximize my profit. So, the set of items to be sold are A, B, C, D and E, and two bidders submit the bundle bids. So, the first bidder submits 4 bundles. For A, C, D, if he is buying together, he is offering 100. For A, B, C together, he is offering 150. For A, B together, he is offering 50. For B, C together, he is offering 75. And so also the second bidder. Now, I have only 1 unit of each. Now, look, we are considering a very simple situation in case of this combinatorial auction. This is a combinatorial auction, very simple situation where each unit, there is a single unit of each item, but the situation can be more complex and you can have more units of each item. But here in this 1 unit is. So, while selling this item, I should be very, very careful. In what way? First of all, I have one objective, I have to maximize my profit, but I have certain constraint as well. What is the constraint here? Constraint is, while selling the item, I should not be selling one item more than once, because I have only one piece of the item. Similarly, while deciding the bundles from each bidder, because one bidder is after all providing all the bidders, I should be only giving considering one bid from the bidder. He is providing many options to me, but I should be considering only one. So, only one bundle from each buyer and only one item is to be, and each item has to be considered only once. Forget about this formulation part. Now to find out the solution, you have to solve this combinatorial problem, which is quite complex, and you have to, for this model which is there in your model base of the decision support system, you have to actually write certain algorithm. But anyway, we are not going to discuss about that, but let us try to find out what are very possible combinations considering these two bundles. In fact, this is your assignment. Find out all the combinations for this particular problem and values of each combination. For example, if I take the combination A, C, D and E from here, this is a valid combination, because each item is getting sold once and one bid from each. So, my price is what I am getting is 150. Now, if I go for this bundle A, B, C and C, it is not possible. So, all the possible bundles are now connected, out of which this solid line which connects these two A, B and C E, here I am getting 200 rupees, here I am getting 50 rupees. So, total one item is not getting sold, that is D, but that is fine with me, but I am now getting more price. So, look, if I consider this one A, B, C and D, all my items will be sold, but I will be getting much lesser price, around 25 rupees less. Here I was getting 250, here I will be getting 225 rupees. So, naturally, even if one of the item is not sold, I will be going for this. Okay. Now, this particular problem, if you can, if you know, have little background, it is a set packing problem, but anyway you do not have to consider about it, concerned about it, and such kind of optimization related things like whether it is a set packing problem, whether it is a knapsack problem, no questions will be asked. So, do not worry. Now, along with this settings, many business rules can also be added. These business rules will appear in the form of constraint in the optimization problem and will make the problem even more difficult. For example, I can introduce the number of winning suppliers. Suppose I am going for multiple sourcing. To minimize my procurement risk, I am going for multiple sourcing. So, I will be choosing 2 or more suppliers. In that case, I have to add it as one of the constraint in the optimization problem. Then budget limit on trade, how much I can spend in case of reverse auction. This is a very valid situation. Then market share constraint, in case of market share, how much business is to be allocated to each winner. So, in case of for example, in case of reverse auction, I can decide how much units I will be buying from each buyer. I can decide I will buy from 2 buyers, that is my number of winning supplier constraint. Then I can have one more constraint, that I will be buying, let us say maximum 600 units from each supplier, that is my market share constraint. Then I can also set reservation price. Now, this is I can decide what is the minimum price below which the seller will not sell, or what is the maximum price above which the buyer will not buy in case of a reverse auction. Then another kind of auction is your double auction. In a double auction, you have a situation in which you have multiple buyers and multiple sellers. Usually such auctions happen while exchanging financial securities. In fact, many financial institutions use such kind of auctions for many years. Example is your New York Stock Exchange, but with introduction of this online auctions, these things are happening in a more convenient manner, in a more automated manner. The activities are now automated. So, there are basically 2 types of double auctions. One is continuous double auctions, which clears continuously, and second one is your clearing house or call auction, which clears periodically. By continuous, which mean the transaction period is very short, maybe every 5 minutes, 5 minutes, 5 minutes will be getting cleared, but in case of clearing house or call auctions, maybe in a day or so it will be getting cleared once. So, this is the situation I was talking about. You have some seller, one seller, you have 4 sellers and you have 4 buyers. Okay. The sellers ask, and only one item is under the one single unit items are under considerations. So, how many items are there in the market? Every buyer is trying to sell only one item. So, there are 4 items in the market. Now, similarly, sellers are asking for 4 items. So, there is a demand of 4, there is a supply of 4 items, there is a demand of 4 items as well. Now, let us see whether all items will be getting sold or not. Now, what are the ask prices of the sellers? First person is saying I will be paying 6 rupees if I get 1 unit, second person is saying 9 rupees, third is 5 and so on. Similarly, the bidders also have their expectations who are trying to buy. So, the sellers are trying to sell at these prices, the buyers are trying to buy at these prices. To find out this market equilibrium price, let us look at this situation. This is my supply curve. At price 3 rupees, that is this buyer, only one item is under sell. With 5 rupees, 2 items are under sell, that is this person is willing to sell. The person who is asking for 3 rupees, he is also willing to sell, he will be getting more price. Why will he stop? He will also sell. Then at rupees 6, 3 items are under sell, at rupees 9, all the 4 items are under sell. Now, look at my demand curve. At price 10, if the market price is 10, this is your buyer's bid. Okay. So, if the market price is 10, only one item will be bought. If the market price is 8, 2 items will be bought, because the first person who is willing to buy at 10 will be willing to buy at lesser price as well. So, then the third person, the price is for 4 rupees. So, now 3 units will be sold at 2 rupees, all the 4 items will be sold. So, when this demand curve and supply curves meet together, that should be my market price. So, my market price is basically this much. So, my market price is, how many items will be sold? 2 units will be sold and at a price, market price 5. At a market price 5, 2 units will be sold. So, with this market price 5, how many transactions will be possible? Now, these two sellers are asking 6 rupees and 9 rupees. So, naturally they will not be able to sell, because their price they are asking is more. And which two, because only 2 items are now under can be sold, which persons will be buying it? Which will maximize my market surplus. So, either these, I mean only the highest bidders will be getting the item, these 2 items the highest bidders will be getting, so that this person, I mean both the persons, both the parties are benefited. They will be getting the item at a lower price and this will be, these 2 fellows will be getting the prices as high as possible. Now, market price is 5. So, the selling only 2 items are getting sold. So, this corresponding winner determination problem with that particular setting can be written in this manner. And the problem is to maximize the market surplus. This is the market surplus, the difference between the ask price and the bid price. So, sorry, the bid price and the ask price, and wherever the where the surplus define difference between the bid and ask. In the last example, where 4 sellers try to sell a single unit of some homogeneous goods and 4 buyers bid to buy the single unit of each, the winner determination problem looks like this, and you have to devise corresponding algorithm for that. Now, besides this simple setting, there can be other considerations during double auction problem formulation. You can go for market aggregation, where the role of the market maker in disassembling and reassembling the bundle of items. So, which means it is no more a single item situation, multiple items are getting sold. These multiple items can be homogeneous or heterogeneous. Then consideration of either buy side item or sell side item or both. So, this disassembling can happen either with the buy side item or at the sell side item or both side. Divisibility. Then in case of again multi item situation, see these are mostly for financial securities, na shares, same shares, many shares of the many unit shares of the same company or from the multiple companies. So, multiple different items, multiple units you can now relate possibly, and homogeneous and heterogeneous goods. Okay. So, with this we finish our discussion on winner determination problem in various auction settings, and these problems are to be solved online. And looking at their complexity, you can realize to make them happen in an online environment, you need faster algorithms. So, this is, so we end our discussion on winner determination problem. Thank you very much.